Assalamu alaikum, good evening. Welcome in Water Chemistry Live class, day 18. Today, we welcome you all to join our class, and I'm waiting for you all connect. And I appreciate your support and courage and continuation with me. I love you all, and I love to share the knowledge I have. This is Jakir from Dhaka, water expert. 15-year experience in water treatment. Is like to share his experience in water chemistry for the advantage of professional chemist, chemical engineer, utility professional, different industry peoples globally. So thank you very much who already joining, and I welcome you all to connect the page, and if you already joined, please share on your wall. And I like to share. I like to have you all sharing. So thank you who already connected, and I'm waiting for you for a bit time to connect more people and to get all connected together. Let's enjoy a song that I like to have, because in this corona period all of you are in very stress, and I like to make you all easy and relatively happy in my mood to get the knowledge sharing. So let's enjoy the song, and I'm waiting to connect more people to start my original topics. Today we will discuss dissolved gases. What are the dissolved gases contained in water? We will discuss today what are the importance, why it is important, what are the impact, and what are the challenges, and how it is important to understand, to analyze, and to test the dissolved oxygen or dissolved gases in water. And let's enjoy the song, and I'm waiting to connect you all who already connected. Please share, and I'm just reversing my camera, and I like to enjoy the song first, then you watch the main topic. So thank you very much. I'm waiting for your connect.
ঘড়ি দেখতে যদি হয় বাসনা চইলা যাও গুরুর কাছে যে ঘড়ি তৈয়ার করে সে লুকায় ঘড়ির ভিতরে মেকার যদি হইতাম আমি ঘড়ির জুয়েল পাল্টাইতাম মেকার যদি হইতাম আমি ঘড়ির জুয়েল পাল্টাইতাম জ্ঞান নয়ন খুলিয়া যাইতো দেখতে পাইতাম চোখের সামনে মন আমার দেহ ঘড়ি
দেহ ঘড়ি সন্ধান করি কোন মিস্তুরি বানাইয়াছে মন আমার দেহ ঘড়ি মন আমার দেহ ঘড়ি সন্ধান করি কোন মিস্তুরি বানাইয়াছে মন আমার দেহ ঘড়ি
একখান চাবি মাইরা চাবি মাইরা দিছে ছাইরা চাবি মাইরা
দিছে ছাইরা জনম ভৈরা চলতে আছে মন আমার দেহ ঘড়ি মন আমার দেহ ঘড়ি সন্ধান করি কোন মিস্তুরি বানাইয়াছে মন আমার দেহ ঘড়ি কেজ বানাইয়া মেশিন দিছে তার ভিতর
রং বেরঙের বার্নিশ করা দেখতে ঘড়ি কি সুন্দর
দেখতে ঘড়ি কি সুন্দর দেহ ঘড়ি 14 তালা তার ভিতরে 10টি নালা
দেহ ঘড়ি 14 তালা তার ভিতরে 10টি নালা
9টি খোলা 1টি বন্ধ গোপন 1টি তালায় আছে মন আমার দেহ ঘড়ি মন আমার দেহ ঘড়ি সন্ধান করি কোন মিস্ত্রি বানাইয়াছে মন আমার দেহ ঘড়ি ঘড়ির হেয়ার স্প্রিং জেবরা কেসিং লিভার হইল কলিজা ছদার বলে আজব কহলে দিবানিশি প্রেম খেলায় দিবানিশি প্রেম খেলায়
ঘড়ির হেয়ার স্প্রিং জেব্রা কেসিং লিভার হইল কলিজায়
ছয়টার বলে আজব কলে দিবানিশি প্রেম খেলায় দিবানিশি প্রেম খেলায় তিন পাটে তার গরম সারা বয়লারে মেশিনের ঘোড়া তিন পাটে তার গরম সারা বয়লারে মেশিনের ঘোড়া 307টি গ্রুপ মারা 16 জন প্রহরী আছে মন আমার দেহ ঘড়ি মন আমার দেহ ঘড়ি সন্ধান করি কোন মিস্ত্রি বানাইয়াছে মন আমার দেহ ঘড়ি
আমার দেহ ঘড়ি সন্ধান করি কোন মিস্ত্রি বানাইয়াছে মন আমার দেহ ঘড়ি
এমন সাধ্য কার আছে ভাই এই ঘড়ি তৈয়ার করে যে ঘড়ি তৈয়ার করে ভাই লুকায় ঘড়ির ভিতরে লুকায় ঘড়ির ভিতরে এমন সাধ্য কার আছে ভাই এই ঘড়ি তৈয়ার করে যে ঘড়ি তৈয়ার করে ভাই লুকায় ঘড়ির ভিতরে লুকায় ঘড়ির ভিতরে
দিন কাটা বারো জুয়েলে মিনিট কাটা হইল দিলে
দিন কাটা বারো জুয়েলে
মিনিট কাটা
হইল দিলে ঘন্টার কাটা হয় গেলে মনটারে তুই কিনে নিলে মন আমার দেহ ঘড়ি মন আমার দেহ ঘড়ি সন্ধান করি কোন মিস্ত্রি বানাইয়াছে মন আমার দেহ ঘড়ি একখান চাবি মাইরা একখান চাবি মাইরা দিতে চাইরা চাবি মাইরা দিতে চাইরা জন ভৈরা চলতে আছে মন আমার দেহ ঘড়ি মন
Thank you very much for watching and welcome you all again. I really appreciate it for joining Ariful Haq, Palash, Junaid Jamil from Pakistan, Abdul Rashid, Shariful Islam from Chittagong. Thank you very much for connecting and thank you for your support. So as per agenda today we will discuss dissolved gases. So as per the 18th class of water chemistry, Asif Iqbal, welcome, thank you very much. So today we like to discuss the dissolved gases. So I just want to ask you a question. So Ali Akka sir, thank you very much. So ask you a question to make you engage. What are the common gases we really found in any water, and it's important for us for as a water treatment. So can you write and comments on so that I understand you are engaged. So just please comment what are the common gases available in water, or that is concern for us. What are the common gases? Can you write? Can you comment on that? What are the common gases is available in water? What are the common gases? Can anyone write, please? Asif, Sharif, Rashid, anyone can write. What are the common gases available in water that is important for us? That is our concern for water treatment or for our any application purpose. Can you please write? What are the common gases? I'm waiting for your write. Welcome, Momin, for joining. Today we discuss dissolved gases in water, and I ask you to a question. Please write what are the common gases. Asif Iqbal, thank you very much. Carbon dioxide and oxygen, thank you. I know many of you already know this. So we had discussed these things that in water usually we have understand that two kinds of things are major in water contain. One is dissolved part, another is suspended part. On dissolved part there are two kind of things is we can have it, and one is a dissolved gases and another is dissolved solids. So today we like to discuss dissolved gases. So dissolved gases, what are the things? Already Asif Iqbal informed, thank you very much. The main two gases that is main concern for us is oxygen, very common. Most of the water from many sources, oxygen is always there. And second is carbon dioxide, depending on the different situation, and many more gases can be in water, but especially ammonia very dangerous for fertilizer plant. A lot of ammonia in the water can come. Then H2S, depending on the location, depending on the process industry where we are working, and many other gas can be in the water. So today all the gases usually we measure in a ppm or milligram per liter, but three gases we discuss today. One is, you understand that, very important, oxygen. Second, we will discuss carbon dioxide, and third, importantly, we will discuss ammonia. So I understand everybody knows that every water contains oxygen. So what is that? It is not the oxygen that entire as in molecular water. So molecule, we know that water in molecule there is a atom of oxygen and hydrogen. I am not talking the dissolved oxygen as a free oxygen in the water, not in the molecular oxygen. So what is this? If you understand for dissolved gases, for any solution or any liquid, how dissolved gas come or dissolved gas contain in water, for that we need to understand that we call partial pressure and equilibrium. Usually in any liquid there is many things can be dissolved, like can dissolve solid, gas also can dissolve. So gas dissolve depending on that we call partial pressure. What is the partial pressure? That means the pressure above the liquid surface of that particular gas. So that we call partial pressure. If you see the picture here is a picture. This is you can say water, and this is the oxygen. So just for understanding, you see here oxygen is 0. If this water partial oxygen is 0, here we consider the water partial pressure. Oxygen partial pressure is 100 millimeter mercury. So this is a case for understanding. So here partial pressure of oxygen is here. Oxygen is available. Thank you Rajesh Mutsuddi for joining. Welcome in your class. So depending on the partial pressure, when any air or any gases come up above the liquid, so usually depending on the temperature, the gas usually like to dissolve in the solution and dissolve based on the partial pressure. If partial pressure exists, so that gas dissolve in the liquid and it comes in an equilibrium. Until the both side of partial pressure become equal, the gas like to dissolve in the water. or even if the water has the gas and the partial pressure of water and above the water is like to be equilibrium unless the gas come out from the water. So it's an equilibrium reaction. If you see this here, the partial pressure of oxygen is 100 milligram mercury and here also 100 milligram mercury, so they are in equilibrium. So at the equilibrium condition, the gas present in the solution is this, that is the dissolved gas. So at any equilibrium condition can be shifted, equilibrium can be shifted on depending on phase, depending on temperature, but the gas at equilibrium condition, gas dissolve in the liquid. So here if you see the example, at the similar pressure, like if partial pressure of oxygen above water level is 100 milligram mercury and below water level 100 milligram mercury, this is an equilibrium condition. The oxygen concentration in water here 0.15 millimole per liter and in air 5.2 millimole per liter. So concentration of oxygen in liquid in air phase are different, but the partial pressure are equal. So depending on the partial pressure, the concentration of gases in liquid varies. Here if you see the similarly carbon dioxide, the same process. Here initially the partial pressure of carbon dioxide in water 0, here is 100 milligram. At equilibrium, both partial pressure in water and in air or in 100 milligram per mercury, and the concentration if you see 3 millimole and 5.2 millimole. So if you see the carbon dioxide concentration is 3 mole, whereas oxygen concentration is 0.15 mole. So why is the difference? The same partial pressure of oxygen, same partial pressure of carbon dioxide, but the concentration of carbon dioxide in water is higher than the concentration of oxygen. Can anyone give me the answer? What's the reason? Similar partial pressure of oxygen and carbon dioxide, but in water carbon dioxide dissolve more than oxygen, or it is always happen that carbon dioxide present more in water than oxygen. Can you give me the answer? A question for you all. Why? Here from this graph we see that carbon dioxide is more soluble in water than oxygen, and with the same partial pressure of carbon dioxide and oxygen, the concentration of carbon dioxide is more in water than the oxygen. What could be the reason? Anyone can try? Arif, welcome in our class. Asanul Haq, welcome in our class. Thank you very much for joining. Today we are discussing dissolved gases in water as a live water chemistry class. So I request you all, please like our page Water Chemistry Live, and a different place, share on your wall and your friends who needs this discussion. RC Pickball, thank you very much. Because of molecular weight, okay, thank you for your answer. I want more answer. If anyone like to write anything, why carbon dioxide can dissolve more in water than oxygen, or why at same partial pressure carbon dioxide more in water than oxygen. Why? What can be the reason? Asif, thank you very much for your try. Anyone like to try? Mominul, Sharif, Ahmed Arif, Rajesh Da, anyone can to try? Okay, thank you. So basically the reason is the gas can dissolve in water in two forms. One is as a free gas, another is it can react with the liquid. So for carbon dioxide, usually carbon dioxide can stay two stage, like it can stay in water as a gas as well as it can react with the water. So if we measure the concentration of carbon dioxide, it will be more than oxygen. But oxygen, that is DO, this is very important property of DO, and it is a universal, and Allah Ta'ala give us this opportunity. Oxygen does not react with the water molecule or water, and that's why oxygen remain as a free oxygen gas. So that's why the same partial pressure carbon dioxide concentration is more than oxygen. Even if you see the right side graph, with the temperature, with the increase of temperature, every gas reduce solubility reduce in any water. but still the same temperature, if you see the carbon dioxide curve and if you see the oxygen curve at the same temperature at lower side, at the same temperature at lower side, you see the carbon dioxide is some cases oxygen is more than you see the carbon dioxide. Oxygen is more than carbon dioxide. Thank you Mesbauluddin for connecting, welcome, thank you. So whatever the condition that here the graph says, if temperature increase, solubility of all gases decrease, that is the fact. So depending on the temperature, depending on the pH, our oxygen and carbon dioxide can dissolve or can remain as gases in water. So let's see, as gases, solubility of gas depend on different things. First, as discussed, if it is reactive, then the solubility will be more. If it is as free, then solubility will be less. Especially for carbon dioxide, can stay in both condition. It can react with oxygen or water, or it can remain as free carbon dioxide. But for oxygen, it is always remain free. And depending on the partial pressure of the gas, if the partial pressure more, the dissolved gases will be more. And depending the temperature, if temperature is high, solubility will be low. If temperature high, solubility will be low. Here if you see the region, the partial pressure high, so oxygen solubility will be high. The partial pressure low, oxygen solubility will be low. If temperature increase, the oxygen solubility decrease. Sharif, for here I am maybe okay. Maybe your cases you are having some net problem, but still I hope that it will record it perfectly and you can rewatch or review later also. Thank you very much. So for oxygen, this is very important. We have to understand with the temperature, oxygen reduce its concentration in the gases. If you see the table says that, and like for example at room temperature oxygen can be present in a very good quality water 7.5 ppm. The same oxygen, if we increase the temperature at 90 degree, the oxygen can stay only 1.6 ppm. So this table give us the idea, even this is very important for boiler feed water or any other application, where we can understand at what temperature what water what DO contain in the water. So if the temperature, this is a quantity containing is like a pure water or good quality water. As a good quality water at room temperature, the DO can be present like 7.5 ppm, and it goes off, the oxygen concentration reduce. And if you say the feed water, like boiler feed water temperature 80 degree, the DO concentration will be 2.9, 90 degree 1.6, and if it is 100, it will be less than 0.05 ppm. If it is closed and there is no other way to come in water, at 100 degree boiler feed water is always very good, but problem is there are other leakage was there. Usually leakage comes, water comes, gases comes in the feed water because of different point of leakage. So if you see the right side graph, oxygen present, if oxygen increase depending on the temperature, if oxygen increase and temperature increase, the corrosion always increase. Even with the temperature increase, oxygen reduce, but still the chance of corrosion going very high. That's for that region, high pressure boiler oxygen is very dangerous. People like to treat oxygen in different mechanically and chemically, and they want to get rid of oxygen at a very negligible level, and we can't allow any oxygen inside the boiler or anything. So dissolved oxygen is the one of the vital reason for corrosion. If you see the two example, the impact of oxygen in any system, this is oxygen corrosion, especially for high pressure boiler or boiler, especially any kind of boiler, the one of the major reason of corrosion is oxygen. So we have to treat oxygen, either we have to increase the temperature, as well as we have to use the deaerator, and as well as we have to use the oxygen scavenger to control the oxygen corrosion of boiler. So if you see the environmental aspect, so the discharge limit or any water, if you like to discharge in any water body, you must have DO or dissolved oxygen greater than 4.5 as per Bangladesh guideline. Thank you Imran Hossain for connecting, thank you. So if you come the next, that is called carbon dioxide, another very important and critical gas that dissolves in water. And this is also the same, with the increase of temperature, the solubility of carbon dioxide decrease, decrease, but it's more than water. If you see the temperature of carbon dioxide, there are around 500 ppm can exist 90 or 93 degrees centigrade temperature. So this is how carbon dioxide can exist, and carbon dioxide exists as carbon dioxide and reacted with the water if it is in liquid form. So this is very important. Even that is also true that if temperature increase, the carbon dioxide solubility decrease. So again, the pH relation between the carbon dioxide, we saw this table at alkalinity. Yes, with the alkalinity and pH there is a relation with the carbon dioxide. So carbon dioxide in water can exist up to pH 8.3 or 8.4. So carbon dioxide can exist in water pH up to 8.3 or 8.4. So we have to be very careful using any boiled water where our pH should not go below 8.3, because the carbon dioxide can pre-carbon dioxide gas can exist within this area, and that can create a lot of corrosion. If you see the free carbon dioxide gas, when it comes in water contact, it becomes bicarbonic acid. So carbon dioxide gas and water liquid, so it can become bicarbonic acid, and that reduce the pH, and that can create corrosion in pipeline and any condenser return system, the steam trap where the steam become the liquid water and carbon dioxide dissolve on it, and dissolved carbon dioxide converted bicarbonic acid, and that create corrosion. And if you see any pipeline corroded like this, where the downward side, that means due to the gravity, liquid stay actually near this side, so that area corrosion and other area is still okay. So this kind of corrosion is predict because of the acid or bicarbonic acid corrosion. So we have to be very careful regarding the carbon dioxide and oxygen, that both of the gases create corrosion for any water body or especially the boiler. So thank you. If you have any questions so far, you can write on comments. The third gas that we like to discuss, that is ammonia, NH3. This ammonia is very dangerous, especially for fertilizer plant, people who work at fertilizer plant, or people who use ammonia in their process, or there is a probability to producing ammonia in the process. Even for effluent treatment ETP, some cases, if the project or the ETP produce ammonia, or ETP contain a lot of ammonia because of the wastewater, the effluent water, if water have ammonia, that can create a lot of corrosion also. So what happen if ammonia stay in water? First, if you see the solubility of ammonia, yes, definitely the solubility of ammonia reduce with the increase of temperature, but still it can have a very significant amount of ammonia. Like if you see the cooling water temperature like below 40 and cooling water temperature below 40, ammonia can stay like around 300 to 400 to 500 ppm. So this is a big amount of ammonia. If ammonia contain like this kind of area, there are a lot of things happen, and that is left side the table. If you see what happened if ammonia contain in water. First, ammonia increase the pH. So it can be good if ammonia exists in water as ammonia. It may help sometime, because in boiler water we use ammonia for increasing the pH. But at this temperature, like especially for cooling water system, if ammonia contain in the cooling system, so this ammonia actually create a lot of issue, because of in cooling system there is always some bacteria, because of the temperature and environment, and it contact with the open air, so always there is a bacteria inside the cooling system. So there is two kind of bacteria, that is one of called is Nitromonas, another is called Nitrobacter. So Nitromonas bacteria, it convert ammonia into nitrifier. You see, first ammonia converted into hydroxylamine and then nitroxyl, and then this reaction helps this Nitromonas bacteria, and that we call nitrifier. So this nitrifier process, this Nitromonas bacteria convert ammonia into NO2, and NO2 reduce NO2, and this ammonia converted NO2, and NO2 is after that, when NO2 convert, another bacteria called Nitrobacter. So Nitrobacter bacteria convert NO2 into NO3, and NO3 is basically nothing but a nitric acid. So if you have dose nitric acid, the pH get reduced drastically, and when pH reduce, the corrosion increase, and by this time when ammonia is high, our bacteria or biocide activity get reduced, lot of chlorine consumption demand increase, and so that chlorine fail to react with the microbiology or other things, chlorine, all the chlorine consumed by this ammonia and other process. So our total biological treatment or biocide treatment fail, and system become foul, and pH reduce, corrosion increase, and all the treatment become failure. So that's why ammonia is very critical, especially the fertilizer plant, ammonia urea plant, and every ammonia urea plant, they are very concerned about this ammonia gases, and they try to control the ammonia leakage from the system, from the process. But unfortunately in fertilizer plant, ammonia tank is there, the exhaust valve is there, a lot of ammonia coming from the air, and especially in Bangladesh government, all the fertilizer, they got a lot of leakage, and one of the biggest fertilizer like Ashugans fertilizer, because of ammonia they are facing a lot of problem, their heat exchanger getting leak and everything. So that's why ammonia is very critical for water. So if you see the impact of ammonia, you see some pictures here. This is a cooler, the cooler become foul because of failure of microbiological treatment, the biocide fail, and a lot of problem happen. So all these things like the tube, this is a U-tube shaped cooler, and this is a cooling tower basin, lot of algae, and because of the failure of biocidal activity, microbiology grow a lot. If ammonia come in water, so this it's a terrifying situation happen in the microbiological process. So this is the three gases we like to discuss today. One is oxygen, another is carbon dioxide, another is ammonia. Thank you Tahsin Alam for joining. So if you have any questions so far, you can ask me or you can write me later also, I can reply. So by the time, I'm sure I'm just nice to discuss today is what are the gases available in water, or what are the concern. Number one oxygen, number two carbon dioxide, number three ammonia, and many other gases inside water. But our main focus is oxygen that create corrosion, carbon dioxide that create corrosion, and definitely ammonia create a lot of problem in cooling water system. So I think if you have any question, you can ask me later also. And that's all for today. Today we finished the discussion on dissolved gases in water, and definitely we welcome you all again tomorrow 10:30 p.m. live class on water chemistry. I request you all, please share this video on your wall, on your group, on your people who like to watch this and who need this. And I appreciate your encouragement and support. Again, during this corona period, the time is extended, so we all understand that the situation will not in our control very soon. It will be extended, and it will may further extended. So we have to be very productive at home by keeping our daily schedule. Please do work what it is work. Keep connecting with your family, keep connected with your customers, and I like to request my team all, please connect with your customer on digital media and share this video to the customers so that they also can enjoy, and they also can learn the things, and they also can utilize their productive time, because most of the people are in very stress. So last not the least, today I request you all, please share and watch on the Water TV page, Water TV group, and Water TV YouTube channel. Please like and subscribe and share you all. And thank you very much. Have a good day. And I like to you all, please keep reading, keep study, continue, and make your life beautiful. Don't be upset, don't be stressed, be strong, be positive, be aware, and be safe. Thank you very much, and good night. So সবাই ভালো থাকেন। আসসালামু আলাইকুম, আল্লাহ হাফেজ।